CSET, Subtest 2. So as we read this question, what we see is it's really a bigger circle minus a smaller circle. And the second thing to add to that is we need to figure out what fraction of a circle it is. So remember that a full circle is 360 degrees, and we want 150 out of 360. Alright, so where we start with, the area of a sector. The entire thing would be pi r squared, and whatever slice we're taking out of it, that's the fraction we want to take out of 360. Same thing with our circumference idea. If we wanted the circumference of a sector, or the arc length it's sometimes called, that's what it's normally called, it's arc length, the full circumference would be 2 pi r. So we should know both of these equations. Both of these are flashcard concepts. Now, we're only using the top one. Looking at this, what we see is that this arc is the outer circle, and this arc is going to be the smaller circle. So, the radius of the outer circle is not 12. The radius of the outer circle is 18. So, we're going to be going pi big R squared, and we have pi little r squared, and we're going to be taking the difference of the two. And the last thought is, it's not a full circle, right? It's theta over 360. So I can do one of two things. I can either put parentheses here and multiply the entire thing by theta over 360, or put theta over 360 and theta over 360 two different places. I'm going to go ahead and multiply the entire thing out front by just theta over 360, or 150 over 360. Right? And that's it in the generic form. And so applying it now, 150 over 360, pi times big R, which is 18 squared, minus pi little r 6 squared. Okay, use a calculator from here, but 324 pi minus 36 pi, so 288 pi, and 5/12 of that. Oh, he's getting old, but I believe it's 120 pi. So 120 pi is our answer. Answer C. There we go. Noting one more thing. In the question, when it said starts from its pivot point, that really meant you have your center.